This video is on finding volume by using the cross-section method. And so here I have the surface function of z equal to 4 minus x squared minus 0.5 y squared. And so this is what the graph looks like. And the base here is an ellipse. And so we call this an elliptic paraboloid. And I want to find the volume of this elliptic paraboloid. And here's the elliptic paraboloid again, and this is the cross section right here when z is equal to 1. And so we'll let z be 1, then we end up with an ellipse like this. And here's the cross section at z equal to 2, and the cross section at z equal to 3. And so here's the surface equation again. And so I'm going to move the x squared term and the y squared term here to the left side, and then move z to the right side. And then divide each term by 4 minus z. Then we end up with this right here. And then multiplying by 0.5 is the same as dividing by 2. And so here we end up with an ellipse of the form x squared over a squared plus y squared over b squared equal to 1. And so this would be a squared and this would be b squared. And recall that the area of an ellipse is pi times a times b. And so for the cross section right here, when z is equal to 1, the area of this ellipse for when z is equal to 1, when z is 1, then a squared will be 3 and b squared will be 6. And so the area of this ellipse for z equal to 1 will be pi times the square root of 3 times the square root of 6. For the cross section when z is equal to 2, so when z is 2, then a squared will be 2 and b squared will be 4. And so the area of the ellipse will be pi times the square root of 2 times the square root of 4. And then the cross section when z is equal to 3, and then when z is 3, then a squared is 1, b squared is 2, so the area will be pi times the square root of 1 times the square root of 2. And so in general, given z, and then the area of the ellipse will be pi times the square root of 4 minus z times the square root of 2 times 4 minus z. And then simplifying, we get pi times the square root of 2 times 4 minus z. So this is the ellipse, the area of the ellipse for a given z. And so to find the volume of this solid right here, what we're going to do is divide it into many slices. And so first, let's divide the interval from z equal to 0 up to z equal to 4. So divide this interval into n sub-intervals. So this would be z sub 0, z sub 1, z sub 2, z sub 3, z sub 4, all the way up to z sub n, which is equal to 4. And then let's call the disk, that is z sub I, distance from the origin right here. And so this would be the ith disk, and the thickness of this disk we'll call it delta z sub I. The distance from the disk to the origin will be z sub I. And so this is the width, the thickness of this disk is also the sub-interval width, or the width of the ith sub-interval. The volume of this ith disk would be the area of the ith disk, so be the area of this circle of this ellipse right here times the thickness of this disk. A few moments ago, we saw that the area of the disk in terms of z is pi times the square root of 2 times 4 minus z. In this case, the distance from the origin to the disk is z sub I, and so we have z sub I right here. And then the thickness of this disk would be delta z sub I. And if we have an infinite number of disks, and then this is what the expression would look like. And we allow n here to run to infinity. And then this part right here, this is the volume of the ith disk. And once again, if this limit here exists, then we define it as the integral from z equal to 0, z equal to 4. So z equal to 0 up to z equal to 4. And then here we have pi times the square root of 2, and then 4 minus z, and then this will be dz. And then the evaluating, we'll get the 4z, and then minus z squared over 2. And then when z is 4, then we end up with 8, and then when z is 0, we just get 0. So the final answer is 8 times the square root of 2 times pi. And so this elliptic paraboloid, the volume is 8 times the square root of 2 times pi. And that's the end of the video.